is the lesson 2 for week 3. And as you can see from the agenda, we have some quite of interesting activities which we'll be doing today. And before that, we will start our class with the recital of Dua. So would you please switch on your camera and also microphone so that we can recite our Dua. Ceria-ceria sengih tu puasa ke tidak tu? Saya sengih ya, tapi saya puasa. Okay, Afsar, Nazrin, Iman, Kamilia, Chadiana, Ashikin, Anani, Amira, Najwa, got 26 of you, got a lot of people, so I should be saying all of you on the screen. Atrisha, Nur Nada, Mashita, Afifah, Azian, Umaira, Alia, Ezwan, Azri, Shafiq, anyone else? 2, 4, 6, 8, 10, 12, 19. Masih ada lagi tu, baru 19. Fazlika, alright, maybe next time 10 je you dah buka video So, bila saya berucap je semua dah ready. So tak payahlah saya tunggu. Cantik baju Syafiqah, Chemical Engineering. Shah Alam punya ke? Tadi kat saya cakap dengan siapa? Saya cakap dengan kamu lah Syafiqah. Syafiqah.
Aduh.
Okey Khairia, baju mana? Shah Alam ke kampus lain?
Baju diploma.
Dah saya dah jaga dah. Tak pernah nampak kat Shah Alam. Tak boleh ni. Kena pakai Shah Alam punya. Beli. Alright. So, kita kira 2, 4, 5, 2, 4, 5, 2, 4, 5, 2, 4, 5, 20, 21. Ada lagi 5 orang. Anyway, we can start right away now. Dia tunjuk lagi baju dia Syafiqah ni.
Saya nak pasang ni.
Yang baru-baru ke apa? Itu apa? Yeah, you ready Syafiqah? Saya dah tengok the ladies berapa kali betulkan tudung dah. Tengok cermin ke apa? Amira baru bangun tidur ke? Okay, alright. So we may start our recital of doa. Who wants to recite the pembuka and penutup? Nazrin macam nak je Nazrin tu. Dah angkat tangan dah ni. Okay, siapa buka penutup? Tunggulah kita ya. Saya boleh tunggu sampai esok. Tapi berhenti sekejap lah. Pergi terawih, buka puasa, solat.
Saya baca doktor.
Siapa? Afsar. Alright. Okay.
Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin wassalatu wassalamu asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajmain. Allahumma fili wa liwalidayya walhamhuma kama rabbayani shaghira. Bismillahirrahmanirrahim.
Amin. Allahumma ja'alni
fi
fi qalbi
qalbi
nura,
wa
fi
fi
lisani
lisani
nura,
wa fi
wa fi
bisari
basari nura, wa fi sam'i nura,
wa
wa
ayyam
ayya
nura
nura, wa
wa
ayya sari nura, wa
wa min
min fawqi nura,
wa
wa
min
min
tahti
tahti nura, wa
wa
min
min
amami nura,
wa
wa
min
min
khalfi
khalfi nura, waj'al li fi nafsi nura. رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقه قولي اللهم افتح علينا حكمتك وانشر علينا من خزائن رحمتك يا أرحم الراحمين.
Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina azabannar. Wa sallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi wa barik wasallim. Walhamdulillahi rabbil
Alhamdulillah
alamin.
Rabbil Alamin. Amin, amin, ya Rabbal Alamin. Thank you to Mr. Afsar. Thank you. You started the dua with the dua for your parents. For those people who still have parents or do not still anymore have parents, it's okay, but we keep pray good dua for our parents. Yeah. All right. So we will start right away our class. I will share my screen and you may switch off your video, but then you will need to switch on back when we are in the breakout rooms. Okay. I think you have seen your slide. Yeah. You can already see your slide, can you?
Yes.
Very good. So I am going to continue. Yeah. So as you see this time, I saved what I wrote specifically for your class, and I could see that we have stopped our lecture until example 3.2, and I gave you the opportunity to be in the breakout room. This is JK. Yes, in the breakout room, and you were in your breakout room. I'm not sure whether you could still remember what you have discussed in your breakout room. So basically, this question is asking you to form your stoichiometric table for those people who were lost at that time, maybe could not focus and so on. Maybe, I don't know, have tried yourself at home to form your own stoichiometric table. And that was the end of part 1, topic 3. And today we will proceed with part 2. And the first slide shows you asking you to prove these equations which you can see from the slides. I think you may want to try this yourself at home because the answers can all be obtained from the previous slides. Yeah, meaning these set of questions are applicable for both batch reactor system and the flow reactor system. So what does it mean? Doesn't matter if it's batch or flow, you can still use the equations which has the function of the initial concentration of the limiting reactant species and also the conversion. So as long as you have these values, the conversion percentage and also the initial concentration of the limiting reactant, you can calculate the concentration of each species in your reaction, yeah, simply by using that equation. So of course, earlier we have seen few equations prior to this one having in the function of the number of moles and also the concentration of that specific species. For example, can it be seen here? Yeah, I have to go back. For example, hold on. Yeah, for example, this one, for batch reactor system, if you want to find the concentration of species B, you need to know the initial concentration of the B itself and the initial concentration of the A, along with the conversion value. But now, you can already straight away use this equation, which you have seen earlier, only the initial concentration of the A, which is the limiting reactant, no matter you are calculating for B, C, or D, and also the conversion. Now, of course, you have this ratio, which is theta, yeah? And that theta, if it's flow system, you can use that relationship ratio. If it's batch of flow, you can still use this theta correlation. Yeah, if it's theta B, then the initial concentration of the B over the initial concentration of the limiting reactant. If it's gas, you can use the mole fraction ratio. Okay. If you know the volumetric flow rate, then you have this upsilon value. Upsilon means, in this case, defined as the volumetric flow rate. The unit is, what is the unit for volumetric flow rate?
Meter cube per second.
Louder, please, Karya. Volumetric flow rate. Huh?
Meter cube per second.
Kenapa tak dengar?
Meter cube per second.
The volumetric flow rate, yeah, yes, that's true. Meter cube per second. Yeah, we have this volume per unit time, and that volume can be liter, and that liter can be converted into meter cube. For example, 1 meter cube is equivalent to 1,000 liter. Yeah, so as long as it's volume per unit time, so it's volumetric flow rate, which is the upsilon. All right. So always remember your units as well for the concentration and the molar flow rate. All right. Now, okay, let's proceed. Please do this at home. The exercise is just to allow you to understand that you can also use this sort of questions for both batch and reactor, and try to get into the fundamental theories. Why is it so? Yeah, and explain the equation. Now, the next slide shows you two kinds of phases, the liquid phase system and the gas phase system. For a liquid phase system, of course, if you use CSTR or any kind of reactor whereby the volume is constant, then you can assume volume is equivalent to V naught. Or the volumetric flow rate is equivalent to the initial volumetric flow rate. Yeah, this is liquid phase system. Doesn't matter if it's batch or flow. Yeah, in this case, the volumetric flow rate is equivalent to the initial volumetric flow rate. Of course, not for the batch, but for the flow reactor system. When the no phase change occurs, meaning at that specific temperature, when the liquid enters the reactor, it stays at the same phase all along, yeah, liquid, even though it produces products. Then you can make that assumption. Either the volume is equivalent to initial volume, or the volumetric flow rate is equivalent to the volumetric flow rate. If it's gas phase system, for some gas phase system has a constant volume or constant volumetric flow rate, then you can use that equation. Yeah, so this equation is quite important where it is applicable when the assumptions are made. These assumptions are made, but not always we can use that set of equation. The A set of equation is the one that you see in the blue box. Might be the volumetric flow rate is not constant due to the change in the total number of moles, or change in temperature, or change in pressure. So when you have that kind of situation in a gas phase system, then you can never use this A set of question, yeah, because we have change of total number of moles, or the change in temperature, or change in the pressure, right? So we have this caution thing there, which you need to remember when you see a situation. What are the simplifications that you can opt for by choosing certain assumptions? In this case, these are the assumptions that need to be remembered, or used, or referred to. Now, when we talk about volumetric flow rate, which is epsilon, which is varying, yeah, we call it variable volumetric flow rate. So this is one of the example that shows the system has a variable volumetric flow rate, yeah, in an ammonia synthesis, whereby the reactants having a total of 4 moles reactants, but producing only 2 moles of product. Yeah, in that case, we can say that the molar flow rate may change during the reaction. So as an illustration there, what is entering 4 moles of reactant, but what is coming out is only 2 moles of product. Yeah, then the volumetric flow rate can never be said constant, or the same as the initial volumetric flow rate. Yeah. All right. But for a batch reactor system, we can also have this variable volume. If it's a variable volume, then you can use this formula, whereby you have this Z compressibility factor. The NT is the total number of moles, as before, the one that you have seen earlier in the stoichiometric table. The air, the universal gas constant, and of course, the T is the absolute temperature in Kelvin. Then we have this P as well, the total pressure in ETM, and the V is the volume. Yeah. Most probably from this equation, you want to know the variable volume, so you can use this formula. Now, in a batch reactor system also, there are some formulas that you can use to calculate certain things. For example, the epsilon and the delta. The delta is simply the summation of all the stoichiometric ratios in the equation. And the epsilon is the delta minus 1 times the ratio of the number of moles of A, the limiting reactant initial, over the initial total number of moles. And the epsilon is also equivalent to the mole fraction of the limiting reactant initial times delta. Then that is applicable if you are dealing with a gas phase system, right? And I think if you could still remember, we have defined the delta and also the epsilon from our previous slide. So please refer to your lecture notes. I'm sure that you already have that in your laptop or your computer. Yeah. And the epsilon can be written as the ratio between the difference of the number of moles, the total number of moles, when we have complete conversion to the initial total number of moles. Yeah, divides by initial total number of mole, initial times the conversion. All right. Now, so this is what I meant by the one that you have seen earlier for the definition of the epsilon, which is the change in total number of moles for complete conversion over, which is this one, total moles fact. Let me see. That is we have NT minus NT naught, NT naught. All right, so this is when we say at complete conversion, yeah? So that is why we have x equals to 1 there. Then notice that the epsilon has no x there because here is equivalent to 1, yeah? So whatever multiplies by 1, then we'll give that particular equation only, okay? Now, for batch reactor system, when we assume volume is not equivalent to the initial volume, when it has a variable volume, those are the equations that you can use here. For example, the partial pressure ratio and the temperature ratios. Yeah. Of course, the volume at any time, the V is variable. At any time, the volume in that batch reactor varies. So we need the initial volume and the ratio of the pressure, the epsilon, the conversion, and the ratio of the temperature. When the volume is equivalent to initial volume, then of course this V is V naught. And V naught is equivalent to V naught is equivalent to V naught and this equation plus 1 epsilon x and the ratio of the temperature. Yeah, in this case, you can use it to calculate the volume or in this case, you know the initial volume as constant. Maybe you want to calculate the pressure and so on. Yeah, because the pressure is in the function of here, the pressure is in the function. If you find the pressure, because we have T and also T naught and T and and T. Yeah. Just to be exact, yeah. If you rearrange the equation, then of course we have T and T naught and P naught as well. Yeah, of course we have this epsilon as well. Just to be specific. All right. Here, if you, this is just mathematics, yeah? When we say the volume is V naught, then of course you can cancel out both sides. So you can use this correlation to find P, having this P naught, T, and T naught, epsilon, and also the X. So this is what I mean, all right? Okay. Do you have any question before I go further?
No, doctor.
No?
No,
Right.
doktor.
Thank you. Tak sempat tengok nama. Right. Kita. Apa saya nampak muka besar. But anyway, I tak nampak siapa yang cakap tadi. Tapi I rasa itu adalah suara Nornada. Betul ke?
Betul, doktor.
Yeay! I tak nampak nama tapi I boleh teka. Tak sangka puasa I berbaloi. Alright. Now, let's continue. Okay, so this is a flow reactor system. Of course, when we have flow reactor system, always remember that we have this volumetric flow rate. Then for a variable volumetric flow rate, the volumetric flow rate can be expressed by the right-hand side equation. So this is applicable when the volumetric flow rate is variable. If it's not variable, if the volumetric flow rate is constant, of course you write the volumetric flow rate is equivalent to the volumetric flow rate initial. Yeah, but this is applicable when the lengthy equation here is applicable when the volumetric flow rate is not constant, which is not equivalent to the initial volumetric flow rate. Then it is influenced by the initial partial pressure, the absolute pressure, the temperature at any time, and also the initial temperature. Right? Now, you could also see on the slide the how we write the stoichiometric table for a flow reactor system having the variable volumetric flow rate. It is much wiser if we could imagine this when we assume earlier when the volumetric flow rate is constant. I'm not sure whether we have that. Let me go back. Okay, like this one. Hold on, ada lagi besar tak? Okay, remember this one? So this is for, of course, this is a very, we have two messages there. Yeah, let me find another slide. Yeah, this one is much suitable. All right. Now, this slide shows you when for a flow reactor system, when we write the general equation having this, yeah, volumetric flow rate. If the volumetric flow rate is constant, then you replace all this by the epsilon naught. If the volumetric flow rate is not constant, then you replace all the epsilon to the equation of the one that you just seen just now, yeah, to this equation, the right hand side. Then it becomes as complicated as this, whereby you can actually detect that from the ratio of the temperature, the ratio of the pressure, and so on. Then, of course, we have the 1 plus epsilon x and so on, yeah? If you try this, then only you can see clearly how does this equation comes into picture. But try to compare this when we write our general equation for a flow reactor system having the epsilon, right? Then you can do that for both, yeah, when the volumetric flow rate is constant or the volumetric flow rate is not constant, right? So I think this would be the last slide before we do our exercises, yeah? Let me see. This is the one that I showed you earlier, but it is the summary of the overall topic 3 dealing with, let's say, their equation. Remember, then you have to ask yourself whether it's liquid phase or gas phase. Then for each of the liquid phase or gas phase, then of course ask yourself whether it's batch or flow reactor system. Then you'll see the assumptions that are used respectively for respective scenario, right? Now, so let us try again the question that we have seen in our lesson 1 with the soap production, yeah, by using the sodium hydroxide and the glycerol stearate. Earlier, I asked you in the breakout room to practice writing the stoichiometric table. But here, in this exercise, it is extended a little bit more by giving the initial concentration of the caustic soda or the sodium hydroxide and the initial concentration of the glycerol stearate. But remember, yeah, when we want to write the concentration symbol, you always use this bracket. Yeah, this is bracket, open and close bracket, where you have this C. Yeah, whatever that you have here. When you have bracket there, it means normally. Yeah, normally it means concentration. So that is why I write the concentration of NaOH, which is the caustic soda, that way. Yeah, it means, okay, if you read this, it means concentration. So we have 10 mole per cubic decimeter for the caustic soda, and the glycerol stearate is only 2 mole per cubic decimeter. And the question asks you what is the concentration of the glycerin, which is the reactant, when we got two scenarios, when the conversion of the sodium hydroxide is 20%, or the conversion of the sodium hydroxide reaches even higher, 90%. All right, so it says there it's a liquid phase reaction mixture, so we can assume the volume is equivalent to initial volume. This is liquid phase, then of course you can use volume is equivalent to the initial volume. This is a hint, yeah. Just to say that it is, maybe it's done in a CSTR with a constant reaction volume. In this case, we know that we can use this formula directly when that assumption is used, yeah, with a constant initial volume to calculate our glycerin, which is DB. Let's say this A plus B. So we have here 3 moles of A reacts with 1 mole of B, produces 3 mole of C plus 1 mole of D. So if you look at both sides, then we have 4 moles on the right hand side, 4 moles on the right hand side. Yeah, so this is balanced, and it means it has this validity in assuming it's a constant volume for that reaction mixture. Yeah, remember, if I go back to our slide, when we have this kind of condition, the left hand side has 4 moles of reactant producing 2 moles of product, that it is not balanced. Yeah, then you can say that the molar flow rate may change during the reaction, right? Then this assumption has to be made. Okay. Now we know also that we can only use this formula. I go here. Yeah, this formula in the blue box when the condition of initial concentration, initial volume, and also the initial volumetric flow rate are used. Yeah, all right. Remember, those are the few things that you have to remember. How to use this equation, what kind of assumptions are valid for that kind of equations, for example. Now, I have a question before you start doing this in your own breakout room. But before we go to our breakout room, we want to do some exercise, Kahoot game. Yeah. But before we go to that, to conclude this example, the calculation of the concentration of species B, knowing the initial concentration of species A and also B, and also at 2 different conversion, yeah, 20% or the 90%. My question would be, make a guess, which one would have, from this reaction, 3A plus 1B producing 3C plus 1D, which species, A or B, is the limiting reactant? What do you think?
Sodium hydroxide.
Tak dengar? Siapa jawab?
Sir.
Siapa? Siapa? Jawapan dia apa?
B, doktor.
B? Ya, B, Mr. Raja. Betul ke? Siapa kata B? Okay, mari kita jawab dekat chat room. Which one is the limiting reactant? A, B, C, D?
B, doktor, B.
Okay, Akasha B. Bolehlah. I nak tengok siapa yang jawab A. Siapa yang jawab C, siapa jawab D. Chat room please. Ada pun? B, Akasha, Afsar, B, Najwa. Syafiq B. Wah, dia ada tanda surat dah. B, dia kata. Tak faham lah Madam Amizoni. Orang kata B lah. Amani B, Kamilia B, Fazlika B, Nonada A. A or B? Nonada, you answer both. A tak aci. Mashita B, Anis B, Hanani B, Ashikin B, Azian B. Anis dengan Azian sama lah. Amani B, Kamilia B, Syafiq B. Saya rasa, Afsar, kenapa you rasa? Dan kita tanya Afsar, kenapa dia rasa? Haria B, Shadiana B, Umaira B, Afifah B, Ashikin B. Okey, yang yakin sangat ni kita tanya kenapa. Ezwan B, Mashita B. Okey, Anis B. Okey. Kita tanya, Karya jawab 2 kali lah. Karya, kenapa B? Karya, why is it B? Dia jawab 2 kali ya. Karya, where are you?
Hello, dengar ke?
Yeah, hello?
Hello.
Yes, why is it B? Karya? Yes, Karya, tak dengar? Cannot hear you, Karya. Okay, then pandai Karya ya. Saya go to the next one. Okay. Saya rasa B. Afsar, why you think B? Sebab dia kata saya rasa B. Mr. Afsar?
Sebab dia punya stoichiometric number dia 1 dalam equation tu.
Meaning? Apa cerita sikit apa berlaku?
Kalau tak tahu, saya rasa sebab dah caustic soda tu stoichiometric number 3. Lepas tu glycerin stearate 1. So maksudnya glycerin stearate tu akan habis dulu sebelum caustic soda.
Pandai pun. Afsar tu kenapa saya rasa?
Sebab saya rasa macam tu.
So saya rasa tu bukan maksud tak sure lah.
Yes.
In my opinion lah maksudnya saya rasa tu. In my opinion. In Malay is
betul.
saya rasa. When I read saya rasa tu maksudnya you're not confident enough. Macam tu. Right? Okay, thank you. Mari kita tanya Nurnada. Why you answer both A and B? Miss Nurnada.
Ya, saya.
Yes.
Typo sebenarnya. Typo, salah tulis.
Oh, typo. Tak apa. Nanti Kahoot jangan typo, okay? Okay,
sorry doktor.
Sorry, saya rugi Kahoot. Nanti typo, you kalah. I am masih sorry kan? Haji je lawak. Alright, so very good. This exercise not only asking you to calculate the concentration of glycerin because we want to see how far the glycerin would finish, would finish at which conversion, at 20% or 90%. What is the concentration of the glycerin? And we should expect that when it reaches its 100% of conversion of the sodium hydroxide, how would the concentration of the glycerin be like? Would it reach 0 or close to 0 or way far from 0 or maybe tak cukup langsung ke negatif apa? Is it possible to have negative values? Yeah, so it already has its the equation balance, then we should expect that when the reaction occurs, then we should expect that the limiting reactant is reaching 0 when it reach its 100%. So that is the theory, So do we get that in our calculation when we do this? I think, it says the let X is defined as conversion of sodium hydroxide, which means moles of sodium hydroxide reacted per moles of sodium hydroxide initially present. In this case, it is saying the basis is on the sodium hydroxide. What does it mean? What have we learned so far in our theory? When we want to use the equation, it is only mainly based on the limiting reactant, correct? For example, this one, this equation, the Ca naught, Ca naught, Ca naught, Ca naught. And that A is meant to be theoretically, from our understanding, the A which is assumed to be the limiting reactant, right? Okay, if you were to say that the sodium hydroxide is the A, then what would you get? If you were to say the glycerol stearate is the A, which is in this case as the limiting reactant, what would you see from your stoichiometric table? So please try to solve this by using stoichiometric table. Yeah, so we'll do that in a breakout room, but first we are going to go for our Kahoot game. Are you ready?
Yes.
All right. Before we go to that, just skim through. I have this question from the examination question. Yeah, you should expect that this semester you may not get the same questions from past years. Alright, maksudnya bukan selama ni kita sama seperti past years. You may not see the same style of asking questions from past years, yeah, because this time is ODL, and it is a little bit, not to say more, but a little bit ODL style, yeah, where you are given time to test on your own and maybe ample time to answer, for example. Yeah, so this is the question that you got from June 2008, a very direct question whereby it asks you to determine the rate constant K. Right, when we want to find the K, we have this equation, A producing B, then we have the concentration data which you got from scientists, your scientists, or you did the experiment your own at varying time. So the rule is to form the data in a linear curve, yeah, and then you should get the equation which is meant to be linear. So please go back and refresh back your theories on the determination of the K, for example, yeah, using Y equals to mx plus C. Then you have to make an assumption first, whether it's first order, second order, or third order, or zero order. For each assumption, there is specific equation. So from that equation, you get a specific equation and you start to plot it. If the plot is straight line, then it's true from your assumed equation according to that order of reaction. If it's not, then you have to try another one. Yeah, maybe first try with the zero order, then first order, second order, and so on, until whichever equation that you assume based on the assumed order of reaction, if it shows a linear line, then it's true based on your assumed order. All right, so this is how you solve that question. This is one of the example, and we also have this example of question from the past year for a plug flow reactor system having a cumular mixture of A and B fed into the reactor and set up a stoichiometric table taking A as the basis. Meaning we are saying taking A as the basis and express the rate law for this expression. So it asks you to form the stoichiometric table with the A as the mole basis and express the rate law for the reaction, right? Okay. So you need to know here whether it's a gas phase or liquid phase. Then we have gas phase isothermal condition and isobaric reaction as your hints for your starting to answer this question, yeah, informing the stoichiometric table, right? So, do you have any question before we go further?
No, doctor.
Alright, so we are going to start with our Kahoot, but first let us take our 5 minutes break, yeah? Can we do that?
Okay,
Yes.
doctor.
Sambil-sambil tu tengoklah you punya nota-nota tu kotlah ada soalan yang you nak jawab nanti. Very easy one, not difficult. Very easy, confirm. Alright, just the basic ones. Okay, so let's start taking our first 5 minutes break.
Doktor tak stop sharing screen lagi.
Dah stop sharing kan?
Dah.
Dah.
Tadi nampak apa? WhatsApp ya?
Saya tak nampak apa-apa.
Mana boleh tadi apa yang nampak Afsa? Saya rasa macam tak nampak apa-apa. But anyway, thank you for informing me. So, welcome back. Are we ready?
Yes.
No. Tadi habis ni Afifah.
Saya jawab yes.
Tak susah pun. Okay, are you ready to start our Kahoot?
Yes.
Alright. Yes, Afifah dah ready. Yay, Afsa ready. So everyone is ready as well, yeah? So I am going to share my Kahoot first. Okay. Can you see my Kahoot?
Yes, Doctor.
Okay. We are going to, pilih apa ni teach ke assign? For self-paced learning for virtual classroom. Alamak. Team mode, classic mode lah. Player versus player. Game option, mari kita tengok. Okay. Oh, classic. Personalized. Friendly nickname generator. On. On. Lobby. Pilih lagu apa? Futuristic. Oh, futuristic. Let's see. Adventure lah. No. All right. So that would be enough. That player practice the first time. No. So, are you ready? Hold on. Yeah. So classic. Yes. It's loading the game pin. I hope you can see it, right? Boleh dengar ke? Boleh dengar
Boleh.
lagu dia tak?
Okay.
Kuat ke perlahan?
Dia slow sikit.
Oh, slow sikit Slow sikit, saya kena check balik lah sekejap ya. Let me check. Sedap lah slow. Gone.
Mira, pin dia berapa Mira? Tak boleh.
Awak lupa kan mikrofon awak. Rezeki. Girls, cover your eyes, girls.
hear louder music?
Okay, it's louder now.
Yes.
All right.
Yeah.
Are we ready now to start?
The
Okay. 27. Ada lagi seorang. 28. Waiting for another person. Oh, sekejap. 28. So I think we should have had all 28 means including me, yeah? So we can start our game now, yeah? So let us start. Ready?
Yeah.
All right, very good. Which is in excess? Hydrogen plus oxygen producing water. So the answer is hydrogen. So we go to next. Ready? Congratulations to Decisive Bee, Smart Wolf, Lucky Glider, Fabulous Finch, Green Leopard. Wow. Congratulations to those high scorers. So we go to the next question. Yeah, ready? 3, 2, 1. Yeah, congratulations to 22 people have got the answer correct. Yeah, so who are they? Who is leading at the moment? Is it still Decisive B? No, it's Smart Wolf. Yeah, Decisive B now becomes number 2. Lucky Glider still Fabulous Finch. Mighty Shark, congratulations. All right, so we go to the next question. 3, 2, 1. I could see that you are berebut nak jawab ya. The question is becoming easier and easier, I guess. So congratulations for 26 people who have got the answer correctly. So now who is still leading? Is it still Smart Wolf? Yes, Smart Wolf, Decisive B, Lucky Glider, Fabulous Finch. What happens to Mighty Shark? Green Hawk is coming up. All right, so let's go to the next question. It's getting shorter and shorter. You're becoming very good at this question. So 18 people, unfortunately. All right. So who is leading? Smart Wolf. Wow, Smart Wolf. Decisive B, maintain. Lucky Glider, Green Hawk, Fabulous Finch. So let's go to the next question. Cepat juga, 25 people have got it right, correct. Thank you. Smart Wolf, maintain. Lucky Glider, Mighty Shark coming back. Decisive B, what happens to you? Fabulous Finch, very good. So let's go to the next question. Up 3 places. Mighty Turtle is the highest climber. Okay. Laju. 20 people, but still got some people who got it wrong. So it's 20 people have got it. Magnesium as in excess. Correct. Smart Wolf, congratulations. Lucky Glider, Fabulous Finch, Green Hawk, Mighty Shark. Maintain. All right. Decisive B, where are you? Okay. Mighty Shark coming up. Back. Thank you. So let's go to the next one. Okay, 26 people are improving. Only one person got it wrong. Siapa tu yang jawab salah tu? Mesti tersalah tekan ni. Alright, so Smart Wolf, maintain. Lucky Glider, Green Hawk, Fabulous Finch, Mighty Shark. Next question. We got balanced answers for correct and wrong. It's first order for the limiting reactant. Very good. So for those people yang salah tu, cuba fikir-fikir kenapa salah. We got more questions coming up. So siapa ni? Mighty Shark. Alright, Mystery Hamster. Congratulations. And let's go to the next question. We got Smart Wolf, Lucky Glider, Green Hawk. Yeah. Next question. Congratulations for those people who got it right, but still some people who got it wrong. 9 people, 2 people, 1 people. Wow. It's second order, yeah, because we got this A to the power of 1, B to the power of 1 for the concentration. So let's see who is leading now. Mighty Shark, yeah, Mystery Hamster, way to go. Smart Wolf, Green Hawk, Great Lobster, coming up. We got a few more questions. Can still do it. On, so let's go. Ini susah sikit. So this is a little bit tricky because you have to do the, the writing to give the answers unless if you memorize it. So the right answer is A, yeah, the red. Only 5 people got it correctly. But the body, so this is the second last question. Who is leading now? It determines whether you an A or B or C. Mari kita tengok. Next. Mighty Shark, Mystery Hamster, oh Prairie Puffin, oh tiba-tiba fokus dia, smart move. Ni mesti ni orang yang suka berkira ni. Kira-kira ni cepat je dijawab, ya. Yeah? Alright, congratulations. The last question will determine whether still Mighty Shark or someone else. Right? This is a little bit tricky, even trickiest, the trickiest. Banyak masa kena spend kat sini, but not so difficult anyway. Mari kita tengok. Last question. So, have you got your final question correct? The right answer is the cubic decimeter squared over mole squared per unit time. So we got almost the majority of you got it correctly. Congratulations, but still some people got it wrong, like the red one. Yeah. Tricky, the red one. What is the difference between the red one and the yellow one? Tengok balik, it's per, sebab saya ada parenthesis di situ, ya. If I don't have the parenthesis, baru boleh kata sama. But I have the parenthesis, dia akan memberi jawapan yang berbeza. Right? But then we got blue answers and the green answers. Then you have to check back how you calculate or how you write your units. Okay? So let us see who is leading or the winner for this time Kahoot game. Nak teka? Siapa nak teka? Let's see. 1, 2, 3. Wow! Wow! Suddenly, Prairie Puffin focus dia yang awal-awal tak dapat tiba-tiba muncul, and Mighty Shark you maintain, but unfortunately you are the third placer. So boleh saya tahu siapa ni? Yeah? You can later on inform me who are they. Alright? Prairie Puffin, Focus Deer, and Mighty Shark. Congratulations. Now, so what do you think of the game? Lemak, sila kopi lah. Saya nak kopi benda lain.
Menarik.
Is it difficult?
Funny.
Huh? Fun? Like it?
Oh.
Right. Congratulations. Nanti kita buat lagi ya. Saya bagi soalan lagi susah. Okay, now we are ready for our breakout room. Are you ready now to go for our breakout room?
Yes.
Yes, very good. So I am going to divide you into 9 groups with 3 persons inside. But when you are in the group, so please make sure that you switch on your video. Yeah, you can see each other and discussing your question. Right? Ready? There you go.